So our story till now, we've been working our way through chapter 4, which to a large degree has been stuff we've already used. Making decisions. We've been using if statements. We've been using else statements. So the idea behind a menu-driven program. You display a list of numbered or lettered choices. You prompt the user to make the selection. You test the user selection. If there's a match, you execute the code for the action. If not, you go on to the next expression. That's making it sound more difficult than it is. You basically just do something like that. One for, you're voting on your favorite characters. Tony Stark. 2 for Peter Parker. 3 for Simon Says. I'm just making up names. 4 for David Dastardly. Okay, and then you let them type in a choice, right? So, CIN into the choice, and then you just have a series of statements. If choice is equal to 1, print, go Iron Man. If choice is equal to 2, say I like Spider-Man better. If choice is equal to 3, you say who? If choice is equal to 4, you say get out of here. Whatever, that's a menu-based program. It can be more, Back in the old days, before you had all these windowed stuff, you would see these kind of things all the time. Press, 1 to create, 1 to format drive, 2 to partition, 3 to totally trash your hard drive, 4 to give up, hope, whatever. So, you'd have some utility. It would display a list. Nowadays, things are done through event-driven programs. You pop up a graphical user interface and you let them click on it and stuff like that. But we're still learning console applications. If you want to do lots of graphical user interface programming, I suggest taking the C# class. C#, we do a lot of Windows-based pull-down menus and buttons and stuff like that. So anyways, that's a menu-based program. Have we already done the menu-based program that I am thinking of? Let me. So you display the list, and then you test their selection over and over and over. You can test their selection with if, else if, else if. Or we used a switch case. Did we use a switch case in that program? That's sounding familiar or not? Alrighty. We could go back and modify our program to use switch case. So, go back. Let's just make a new one. It won't take long. On second thought, I'd really like to reuse that code that we already had. So, if you just happen to have your sphere materials density one ready, go ahead and open it. If you don't, you can get the source code for it back here in one of these two folders, Sphere Program Complete. So go and open the Word doc in Homework 5 Sphere Assignment Complete. Go and grab all the C++ code, not the Python or Java or whatever's on the next page. Yeah. Create a new CPP file. Remember to always create a new project. If you open an old project and then add a new CPP file to it, it's still going to be running your old code. It might even complain about having multiple mains in it, multiple main methods, functions. All right, so once you've done that, this code ought to look awfully familiar. If type is equal to 1, ice. If type is equal to 2, density is whatever. We're going to change this to switch case. The syntax for that is you do switch, and then you give it the variable you're switching on, which is the same one you did your if statements on. And then it looks like this. Notice I'm leaving these other if statements down here, but we'll eventually comment them out or delete them. So case 1, if they chose 1, it was ice. So I'm going to add a comment to that effect. If they chose 1, the density of ice was 55.0. And then I'm going to add a break statement. The break statement will make a little bit more sense in a minute. Aha. For some reason I declared type as a double in mine, even though it should have been an int. We better cast it to an int right now. So where it says switch type, I wish I hadn't done that. Do switch the integer version of type. That was just to fix the fact that I should have made, you know what, don't do that, that's annoying. Instead, go up here and where type is declared on the very first line of code under main, cut that out, hey, cut that out, and then declare it as an int instead. That'll fix the problem without doing any weird casting. All right, now back to our cases. We did 1, which was ice. Case 2 was aluminum, so its density was 168. Break. And in case 3 was gold. And its density was much higher, 1203. Density is equal to 1203.0. Not sure why I'm adding .0 to everything. If it's .0 all the way down, then who cares? Anyways, and then break. Now if you opened your code, you may have all the other choices already have been implemented. That was bad English. Down here in your if statements. And you could add them all to your cases as well. Just leave these if statements down here so we're not breaking your code. But do add a default. Default. We're going to print a message, cout unknown choice, setting density to 1. Which I think is what we did the other time. No, we didn't. We didn't have a final else in my code. Maybe you do in yours. Set density equal to 1, and we're good to go. So what does this do? It does the same thing as our if statements. It's like saying if type is equal to 1, that's the density. Else, if type is equal to 2, that's its density. Else, if type is equal to 3, that's its density. Maybe that looks worse. Maybe you like your if-else's better. Maybe that looks better. Kind of just depends. You know, it's the same exact logic. You can do something weird, which makes it not the same exact logic. And that's remove these break statements. But we'll talk about that in a minute. What the break statement does is once it hits one of these, like it sets the density equal to 168, when it says break, it comes down here to the bottom, past the enclosing brace. So break just says stop doing this case. Go to the bottom of the switch. We're done. That way these choices are mutually exclusive. That way these choices are mutually exclusive, just like they were here. Sorry, pardon me? I thought I heard a question. I thought I talked over you. I am hallucinating. Alrighty. So this looks maybe a little bit lengthier, but it maybe to you it looks a little bit more structured. One reason it looks lengthier is because we didn't put our braces here. You know, that would have fluffed out the length of this a little bit. If you're working on a version that already had all the other materials, go ahead and add them. But I'm going to walk around and make sure everybody has this working. the normal example of the case statement is something like this. Here, let me print that out for you. The classic example that I guess I'd usually use for these things is to do something like this. I'm not going to mess up our pretty code that we already had there, but something like, you know, cout, don't type this in, enter score, enter test average, let them type it in, then do a switch on it. But if it's not an int, we better make it an int. So int average is equal to the integer version of the average, and then we can do our switch on it. So switch based on AVG. This is actually a really bad way to do it. What am I talking about? What if we did the grade divided by 10? Because then it'd be a 10 or a 9 or an 8 or a 7 or a 6 or a 5 or a 4, right? Because if they enter a test average between 0 and 100, then if we divide it by 10, it'll be between 0 and 10. So now we can switch on it. Case 10, they made 100. Cout 100%, amazing. And then break. I ought to be doing this in the editor because it spaces it out easier. But anyways.
Why not just do with Ifelse?
This just makes it look more structured, but there are things you can do with cases that you can't do if else. But if you're not going to do one of those things, then if else works just as good. So you can kind of toss switch away in your head, but on the other hand, you'll probably see other people use it a lot because they like the way it makes the code look structured. So if they made a 9, it's still an A. I'll type this in. If they made an A, you know, it's a B. Don't know why I'm marking exclamation marks on everything. If they made a 7, that's a C, and that's where we're going to stop. Otherwise, and again, really harsh grading scale. If you don't make an A, B, or C, you failed. Case failed. There. I'd be really happy if my professor told me I failed and they put a smiley or, you know, a frowny after it. Okay, so there we go. There's our switch case for doing that. And yeah, we could have done that with if-else's. I'm going to give you an example next of something that would not quite work with an if-else. Maybe, maybe not. Did we already do the telephone example where we were typing in a digit? Are we really sure we haven't done switch case? I guess we haven't. Okay. So do you remember your old phones, your flip phones? And by the way, I tried to buy a flip phone for a family member who used a flip phone for the past 70 years and didn't want a smartphone. They're hard to find nowadays. But anyways, if you had this keypad, it's the old-fashioned one. Remember this one, and you were going to send a text message? So if you wanted to send an A, you'd press 2. But if you wanted to send a B, you'd press 2, 2. Then if you wanted to send a C, you'd press 2, 2, 2, like that. You could do this more easily with switch than you could with if-else's. And let me see if I can give you an explanation, an example. Heck, let's go ahead and do this one. Let's make a new project. I'm going to call mine texting October 5 or October 5 texting. Add a new item, an empty file. IO, stream, string, CMath, just on any off chance we start raising something to the power of. I doubt it. Using namespace, std, int main. Mac users don't need to type the system pause. System pause. Return 0. Okay, now we're good to go. We're going to ask the user for a letter, and we're going to print out the series of keystrokes required to display that letter. I think this will work. So cout, enter a character. Now we need a character to hold our data, and I put my arrows going the wrong way. Cout, arrow, arrow, enter a character. The arrows go towards cout. I need a character to read it. So char space ch and then cn into that character. And now we're going to arrange a switch case so that if they type in an A, we just print out 1, 2. If they type in a B, we print out 2 2s. If we type in a B, 3 2s. So switch on the value of that character. Now bear with me. It's going to look odd that I'm arranging it in this order, but go ahead and bear with me. If they typed in a lowercase a or an uppercase a, but I'm not going to start with a. Sorry about that. Lowercase c or uppercase c. I'm messing up my formatting here. Case lowercase c, case uppercase c, cout a 2, because that's what you have to type. Don't put a break though. And in case lowercase b, case uppercase b, and since we're dealing with characters rather than strings, that's why I'm using the apostrophes, the single quotes. Cout a 2, don't break. And then if it's an A, lowercase a, case apostrophe lowercase a colon, case apostrophe uppercase a colon, cout another 2, and then break. Now let's put it in a loop so that they can just keep typing in characters. Yeah, we didn't do the whole alphabet. We only did 3 letters, but let's still put it in a loop. So scroll up to the top, even above that cout, but below the main, just do while true and put an opening brace. Delete that close brace that it automatically inserts. And then down at the very bottom, before the pause, if you have one, put the closing brace before the return statement. So I just added while true to the top of my code. I'm going to go down here and put a closing brace there. And I see something I need to add after my switch statements. My code is looking a little bit messed up. It's not tabbed properly, or at least I'm suspecting it's not. So I'm going to do Edit, Advanced, Format Document, and see if it makes a difference. Meh, it looks the same. Okay. So go down here after your switch statement. By the way, have I shown you all this? If you hit Control, open curly brace, or close curly, nope, it's not doing it at all. Must be another editor. Okay, close curly brace. If you hit Control, close curly brace when you're sitting on a brace, it takes you to its matching open brace, or vice versa. So here I'm sitting on the open curly brace, I hit Control, close curly brace, it takes me down to the bottom. Anyways, right here, after our last case and after the closing brace, we want to write out a line feed, or an ENDL. It'll make sense in a minute. Now I'm going to run it. Hopefully. All right, enter a character. A, B, C, 2, 2, 2, 2, 2, 2. You know, in probably about 3 or 4 more years, I'm going to get students who've never had to send a text message using that. In fact, smartphones have been around for 10 years, so it could be that there are already people. If you've never had to type that, I'm sorry that this example no longer makes much sense. But you can always compare it to this. So if they're going to type a D, they're going to press 3 once. If they're going to type an E, they're going to press 3 twice. If they're going to type an F, they're going to print, 3. They're going to have to press 3 times. So who doesn't have this part of it working yet? Because we're going to monkey with it a little bit more, and I don't want to go too far.
What would cause C out to be highlighted red, but it's only one and the rest aren't?
Good question. Does it look like this? No, probably not.
It's the first two, it's where it says enter a character, and then the CN is highlighted, but everything else under that.
That's on your screen, right? Not on mine?
On mine.
Okay, let me come look. It's a little bit. I'm going to put the lowercase c and the uppercase c on the same line, and then the C out statement on the same line. I'm going to put the lowercase b and the uppercase b on the same line, and the C out on the same line. The lowercase a, the uppercase a, put it on the same line. And I really wish that Microsoft wouldn't tab, every time we've had an opening brace, what did we do after that? We indented, but Microsoft, when they reformat, take those away. I'm going to put them there. Okay. This is looking a little bit different from our else ifs. And in order to implement else if, it would require more C out statements. We couldn't get away with just, well, I don't know if that's true. But what we're seeing here is known as fall through. I'm going to word it back the way it was, and I'm going to put the word break here, but I'm going to comment it out. You don't need to do that. So it's going back to the way it was a moment ago. So if the break is missing, it falls through and executes the next line of code, which is useful for doing things like this. If they typed in a C, it'll jump here. Well, there wasn't even anything to do, but it sure wasn't a break, so it also jumped to here, and it prints out our 2. But there's no break there, so it keeps running, and it prints out another 2. And there's no break there, so it keeps running, and it prints out a third 2. And that's how we got our C to print out 3 2s. Whereas for the B, they type in a B, it does a switch on the B, it immediately goes down to here, and whichever one of them catches it, it prints out a 2. Since there's no break, it keeps running, and it prints out a second 2. So that's known as fall through. If you're designing code that deliberately makes use of fall through, you probably ought to document it. It's not a bad idea to put the break statement there, comment it out, and then explain why. Now in this one, I'm not even sure how to explain it. I'm not going to follow my own little rule there. But that way, the next person who comes along in the code doesn't go, oh my gosh, they forgot to put a break statement. Put the break statement there and then run your code. Because what would happen if I had that break statement there and they typed in a C? What would it do? It would just print 1, 2. I'm going to go ahead and run it like that. Okay, so an A is 1, 2. A B is 2 2s. Great. A C, oh man, it's 1, 2. It's not what I wanted. So we don't want the breaks there, but we want it here, because whether we have printed out 1, 2, or 3 2s in a row, at that point we want to stop, because we don't want it to keep going on and start printing 3s and 4s and 5s. Let's go ahead and do the 3s and then stop on this example. So you're going to need more cases, right? Uppercase C, lowercase, D, E, and F. I'm going to arrange it like this because it's easier for me just to copy and paste it if I have it like that. So I'm going to highlight all of that code, regardless of how you have it formatted. Then I'm going to come and I'm going to paste it, and I'm going to make it, this bottom one, a D, lowercase and a capital D. The one up above it, an E, lowercase and an uppercase E. And then the next one, a lowercase f and an uppercase f. But it's not printing out 2s in that case, it's printing out 3s. So that's my new block of code right there. Keep that break there, that one above that A. Excuse me, that one above the F, the one underneath the A. So I don't know if I've sold you on why you would use if statements, but you can see that it's kind of a different way of looking at it. Yeah, you could just write one great big if is equal to a lowercase c or uppercase C, print out 3 2s. Else, if it's a B, print out 2 2s. If it's a, print out 1. I won't argue that. You couldn't do this with the same thing. What would be really neato keen is if we let them type in an entire message and then we showed the digits that they would have to press to get that message. So if I typed in be home soon, it'd print out a couple of 2s and a couple of 3s and a space. I forget even how you generate a space. I guess 0. Well, we can look. Yeah, this one stops it. Yeah, there we go. No, come on. Anyways, there'll be a space down there. I said, I'll trust us. I think I see a space on this one. Okay, so that's the switch statement. I'm pretty sure by this point we've talked about ifs and ors. You can get yourself into trouble by leaving break statements off. What if I did it like this? This code that printed out an A, B, or C. If they made 100%, what's it going to print? If average is equal to 10, it prints out 100% amazing, and then it prints out A, and then it prints out B, and then it prints out C, and then it prints failed. And so whoever earned 100% is going to be really unhappy because it printed out failed at the end of their grades. And then if they earned an 80, which got turned into an 8, it would jump down here and print, you made a B, you made a C, and then failed. So the breaks are really important. Do you have to add a break after the default? No, because it's the last thing. There's no fall through possible. Will it cause it to crash if you do that? I don't know. Let's go give it a shot. I'm going to put a final break. Oh, I don't even have a default. That's not good programming. We need to put a default and explain why they didn't get any output. Cout the character followed by a space is not recognized /n. So if they type in something we haven't implemented yet, so if they type in a J, it says J is not recognized. And what prompted me to notice I didn't have a default is I wanted to see if it would be a syntax error to put a break on my default. No. Does default even have to be the last thing? You could take that default, I'm going to cut it and move it up to the top of my switch statement above the C, B, and A, and it still works as long as you put your break there. In that case, the break is necessary because otherwise it'd print not recognized and then it'd start doing this to stuff. Almost everybody on the planet who ever programs in a language that supports switch puts it at the bottom. Let's go down and put it there, back there. Where you used to see switch used a lot is if you're a Windows 3 or 95 programmer. This is back before they had libraries that made programming Windows graphical user operating systems a little bit easier. You had to do something called an event handler. And you would write some code, and then it would call your code with a numeric value stating what event just happened. And every event that can happen to a window sent a different number to your code. If you move the window, that was one number. If you minimize the window, that was another. If you clicked on a button inside it, that was another. If you turned a slider, that was another. So you had a huge switch statement in what was called the event handler, responding to all of these window messages. I wonder if I can spot a quick example of that. Event handler Windows messages. I'm looking old school. Windows 3.1. Message loop. So typically what you did is you called a function called getMyMessage, and then you would have a whole bunch of messages, a lot more than what they just show here. And as a matter of fact, that one's pretty pathetic. That's a really pathetic example of it. I want to find one more, and then if I can't find it, I give up on this. Well, that's taking too long. I'm impatient. Yeah, forget it. Alrighty. Just trust me. You had hundreds of different events. Everything that could happen to a window or a control, your program had to be able to respond to it. And if you messed up and you made one of those event handlers do something like call a loop that processed too long, rather than returning control back out of it, then the program would freeze. And you've still seen those, I bet, where you grab the window and you move the window and it leaves all these lines around it, and or it says program has become unresponsive. There are still some things that can lead to that. It just means that there's some event handling code in the program that called a function that's not letting it return. And it's gone into an infinite loop or something. Wrong. Right. Validating user input. That's when you inspect the input data to make sure it's acceptable. You can perform various tests. Is it within a valid range? You're asking them to type in somebody's age. You can make sure it's not a negative number, and you can make sure it's not more than 200. Reasonableness, that kind of falls into the same category. If it's a valid menu choice, if you chose something that wasn't among our various materials, wood, ice, whatever, then we should have displayed, invalid choice. And to prevent somebody from dividing by 0. So you're creating a test score program. You might want to make sure that they can't type in a negative value for their test score, that kind of thing. Comparing characters and strings. Characters are compared using their ASCII values. The ASCII value of A is 65, which is less than the ASCII value of B. And so that's how they get sorted. And did I talk about ASCII charts yet in this class? I'm going to look at Olivia because I know that you've sat through this lecture already. Have we talked about ASCII charts? Have I Googled up? Alrighty. Since computers, all they know are numbers, they don't know an A from a B from an exclamation mark or anything like that. Every key that you can type in on your computer keyboard has to be changed into a number. So if you type in the name Abe, A-B-E, in all caps, the computer records that as a 65, 66, 69. Those 3 numbers get stored. We did talk about hex. So if you type in ABE and you wanted to view it with a text editor, you'd see a 41, a 42, and a 45. And let's prove that to ourselves. Go up to your start box if you're on Windows. You just get to enjoy watching this. You could try to create a text file and then do the same thing. Type ABE with all capital letters and then BAD, ABE, BAD, and then save that. Save it to your desktop or something, or to your favorite C directory, and just call it abe.txt. Once you've got your text file made, go to, I'm going to spell out the site, hexed, HEXED, .it. So you can see it's the word hex edit, but it's got a period before the IT. And when that comes up, do open file and go and find that Abe file that you just created and check it out. There are 3 numbers there separated by some numbers that start with 0, and then 3 more numbers there, and then some more numbers that start with 0. These numbers that start with 0 are control codes. They actually are the same thing as a /n. If we look it up, one means new line or carriage return. So if we look at it from here, a 41 is an A, a 42 is a B, and a 45 is an E. 0D, 0A, and then our 42 is the B, our 41 is the A, and our 44 is the D. If we go back to our ASCII chart, we see that's the case. 41's an A, a 42's a B, a 45's an E. So if I was going to type in these numbers in my hex editor, 4D, 4F, 4D, what's that going to be over there in the text part of the window? 4D is a M, if you can see it. I know this is pretty small. A 4D is an M, a 4F is an O, and a 4D is another M. So go back to HexEdit and add those numbers to it. Click right there at the end of that string and type in 4F And even if you couldn't create the text file, Olivia, go to hexed.it and do new file, and then type in 4F, 4D, 4F. I got that backwards. It was 4D, 4F, 4D. I've got to change it. 4D, 4F, 4D, and then I want those control characters. 0D, 0A. And we see that it says mom, Abe, bad, mom. I don't see a save, but I do see an export. Let's see if export will save our file. Do export, and then open that file that I just created, and we should see that it says Abe, bad, and mom. So we just modified our file by typing in 3 hexadecimal values that translated into keyboard values, ASCII values. So whenever there's a string, you ask somebody to type in their name, you ask, or they're typing in a URL like this or whatever, it's translated into a series of numbers because all the computer cares about are numbers. It doesn't have any way of storing data otherwise. Music files are just streams of numbers. Images are all just streams of numbers. They're just stored in a specific format. So, characters are compared using their ASCII values. A lowercase a is less than a b, and that way when they're sorted, the a's are up at the top of the list, and the b's are in the middle, and the c's are underneath those. But there's a quirk about ASCII, which is lowercase letters have higher values than uppercase letters. So if you had 3 song titles, but they were capitalized differently, if you had a song named Hello, and then somebody else came in and added another song called Goodbye. I don't know why I even said Goodbye. I guess I was going to be ambitious and actually put, real song titles. And then one more called I Love You. And then another one called Abracadabra. When you sorted it, here's how it would look. The uppercase letters are considered smaller than the lowercase. So it would print out hello. Oops. It would print out I love you. Then it would get to abracadabra. And then it would print goodbye. And that's probably not the sorting you were hoping for. If you were looking at a list of songs on your player, you'd want, abracadabra to be first. And A, B, C, D, E, F, G, H, I. You'd want I love you to be last. So these strings that we look at in our programs, when we do comparisons with strings or whatever, they're actually comparing values. So we did a C, a B, and an A, which is a 43, a 42, and a 41. Just to get weird on us, change this C right there to an OX43. And change that lowercase, well, actually we should do it on the uppercase letters. Sorry. Change that uppercase C to an OX43. Change that uppercase B to an OX42. And that uppercase A to an OX41. And what does that OX mean? It means it's a hexadecimal number rather than a base 10 number. The program would work just as well. We could still type in a capital C and it would work. Why? Because a capital C is equal to the hexadecimal number 43. That's how it's represented in the computer's memory. I'm going to hit undo a couple of times. So after you try it out, run it, make sure that you type in a capital C and it still prints 222 following that scheme.
Are those O's or are those zeros?
Zeros. Sorry about that. These are actually zeros. 0x43, 0x42, and 0x41. And when I was reading this out, I may have been saying OX, for which I apologize. These are zeros in front of the X's. All right, once it works, go ahead and undo that, because when you come back to the code later, you're not going to want to be looking at 43s and 42s and 41s. You're going to want to look at capital C's and capital B's and capital A's. So I'm going to change those back, just with a couple of undos. Or just type in capital C, B, and A again. What was that 0D, 0A business we were seeing here? If we go back to our ASCII chart and we zoom in here, a hex D is known as a carriage return, and a hex A is a line feed, and a hex 9 is a tab. A hex 8 is a backspace, so each time somebody hits backspace on their keyboard, it's sending a, an 8 to your computer. And each time they hit the tab key, it's sending a 9. And then there's some weird ones. Vertical tab. That's like a say what, but just remember those old scrolling printers they used, with the paper with the perforated holes down the sides, vertical tabs, whatever. Then there's all sorts of really obscure ones that really aren't used in everyday computing anymore. This is stuff that was from the 60s or whatever. We're not using. Okay, there's the escape key. But anyways, so in DOS and Windows, especially in Notepad, every line you type is separated by a 0D, 0A, a carriage return line feed. But if you make this on a Mac, then it's only going to have 0As, I believe. It's only going to have line feeds, and the carriage return is implied. And the same is true of Linux and Unix, and I believe the same is true of most Windows programs now. But Notepad still inserts both the 0D and the 0A. So comparing string objects. In this language, unlike other ones, you just use equal, equal. Or if you want to see if one is sorted before the other one, you can use less than. In Java, we had to use dot equals. If string 1 dot equals string 2. Don't have to do that. I'm only mentioning that because some of y'all just set through Java. The conditional operator. Did I talk about this? Does this syntax look familiar? I thought I had. X less than 0, question mark, something, something. Yes. Yeah. Okay. Here they're using it a little bit differently. I would never use it in this syntax, but it works. The way that I used it was this. Really don't need more abes, but whatever. X is equal to, if the temperature was less than 32, question mark, I wanted to set it to 100, else I wanted to set it to 0. Whatever. It would evaluate this, and if it was true, then 100 would get copied over into X, else 0 would get copied over into X. Now C++ supports some perversions of that syntax where if this is true, it executes that, else it executes that. Now that's just writing an if-else, right there in one line, which you could do anyways, right? You could just write if x less than 0, and then y is equal to 10, else z is equal to 20, and it would work just as well. So I don't agree with that, but yeah, it works. This is how most people that I know use it. What's weird about this one is that it has a possibility of modifying two different variables. If this is true, it modifies the value of y. If this is false, it changes the value of z, which just seems wrong to me. But I'm not as cool as book authors. The switch statement, what do you know? We've already done it. In some cases, you can use it instead of a whole bunch of if, else, if statements. Why do they say in some cases? Well, the switch has to be an integer type, meaning it has to be a whole number. And we just saw that characters are really whole numbers, right? That M was a 4A, and that C was a 4-2 or whatever. So characters are integer types, so you can do a switch on a character. But you can only do a switch on things that are whole numbers. You can't do a switch on a float or a double. It has to be a precise int. It can be anything that's a whole number in this language. And just saying that, something is equal to 10.0, that's still not a whole number, because it could be something else. It could be 10.0001 or whatever. But anytime you can change your input into ints, integer types, you could do some kind of switch statement on it if it felt good. The other time when it makes no sense at all to try to use switch is if you're trying to do ranges. You know, if you want to see if something is water, so you're going to make sure it's greater than 32 degrees and less than 212, it's completely inappropriate to try to use cases. What are you going to do? Case 33, case 34, case 35, case 36, all the way out to 212? Nah, you just write if temperature's greater than 32. We are about done with this. I don't see anything left in this chapter for us to do. Okay, your homework is going to be to take that texting program, which I hope you understood. The reason I hope you understood is because you're going to finish it off. So you're just going to make it handle all the characters between A and Z. So in the program assignment for it, I'll paste that little keyboard picture, you know, a little keyboard picture. That one. If you feel like adding space, picking a key for space, thought it was 0, then go ahead and do that. So if they want to send a Z, you're going to want to print out 4 9s. If they want to send out a J, you're going to print out 1 5. Does that make sense? Take what we already did. Probably take you 15 minutes of editing, if that, to get it working. We all good? All right, there is a quiz over Chapter 4. It's already out there. I'll be checking very often to see if you finish it so that I can grade it, get it back around to you. It's like if you do it over the weekend, you know, that'll be plenty of time for you to get some feedback on it. All righty, unless there are any questions, then we're done.